Okay, so we will solve two questions, one from the textbook and one from the study guide. Let's start first with the textbook. It will be problem 5. .557 from the textbook. I assume you have the textbook in front of you. So the question reads the following. A large family has solved its food shopping problem by connecting 3 shopping carts together with 2 horizontal ropes. The masses of the loaded carts are M1 15 kilogram, M2 13.2 kilograms, and M3 16.1 kilograms. Neglect friction. A third rope, which pulls the first cart, makes an angle of theta 21 degrees above the horizontal and has a tension of magnitude 35.3 Newton. Determine the magnitude of A, the acceleration of the carts, and B, the tensions in the connecting ropes. So at the beginning, we will start with formulating the problem. So we will formulate the problem this way. We will draw the ground first, and then those 3 masses that represents the carts, 1, 2, and 3. There is a rope that is pulling this is T equals to 35.3 Newton, right? Then the angle here is 21 degrees. Then I have 2 connections of ropes between those 2 carts. So this is M1, M2, M3. So if I continue to draw the diagram for the forces applied on those masses, it will be, I have here Fn1, Fn2, Fn3. I also have Fg1, Fg2, Fg3. Okay, so if I assume that my coordinates positive x, y this way, then I can project this tension on the x-axis. Then this is T cosine 21 degrees, the green one. So also I will write the masses M1 as 15 kilograms, M2 is 13.2 kilograms, M3 as 16.1 kilograms. So if I look at the system as a whole system, okay, yeah, this is question 557. 5, chapter 5, number 57. What else do we have? We have here this tension. I will call it F1, F1, F2, F2, that are equal and opposite based on Newton's law. So if I am to write the sigma F equals to ma, where a is the acceleration, then for the whole system, I have t cosine 21 equals to m1 plus m2 plus m3 times a. Now, the tension force is given to me in the question as 35.3 newtons. So this is given. So if I substitute 35.3 times cosine 21 0.93 equals to m1 as 15 plus 13.2 plus 16.1 a. Then I have a equals to 35.3 times 0.93 is 32.95 divided by 44.3. Then the acceleration a is 0.74 meter per second squared. Some students are late and coming. Okay, so this is the acceleration. And this acceleration is in the direction of the pulling rope. The second part, part B, is find the tensions in the connecting ropes. We need to find the tensions in the connecting ropes, which is F1 and F2. So how do we do this? Then we look at every cart at a time, one cart at a time. So if I take, this is for part B, if I take the first one, where I have here F1, Fn1, Fg1, and then T, and this T 21 degrees will be projected on the x-axis, and my coordinates are defined as positive x this way and y upward. So this one again is T cosine 21 degrees. Then applying Newton's law, sigma F equals to ma. We have those forces as in the direction of the motion as T cosine 21 degrees minus F1 equals to m1a. And a is the acceleration that we just calculated. So T cosine 21 is 32.95 minus F1, the one that we want to calculate, equals to M1. M1 is 15 kilograms times A, the one that we just found, 0.74. F1 equals to 32.95 minus 15.74 is 11.1. This means F1 is 21.85 Newton. So this is the tension force between cart number 1 and cart number 2. Now, if we want to calculate the tension force between cart number 2 and 3, we can look at this last cart that has only one force applied on. So this one is, I have F2, Fn2, sorry, 3, Fg3. This is mass 3. Then again, sigma F equals to ma. I have here F2 positive equals to m3 times A. F2 equals to m3 is 16.1 times the acceleration 0.74. This gives F2 to be 11.91 Newton. So this is the tension force between cart number 2 and cart number 3. Any questions so far? We're good? Okay, so let's move now to the second question, which is question number 2 from self-test number 3 from study guide 3. Study guide 3, self-test 3, question number 2. Okay. I'll read the question. Consider the following system: a block resting on an inclined surface connected to a block suspended from a frictionless pulley. So the graph is so the graph is as follow. I have a box here, A. I have a pulley here, another suspended box, B, 68 degrees. I have MA as 28 kilograms, MB as 21 kilograms, and they are at rest, which means A is 0. There's no acceleration there, no net force, so it is at rest. The surface is frictionless, the pulley is frictionless. We need to determine the magnitude of the normal force on box B. So for simplicity, let me replace those boxes with masses like this. So this is B, this is A. So we need to calculate the normal force on A. So let's draw those forces. So I have the normal force pointing F and A this way. I have the tension force T, which is the same as here as well. I have the gravitational force FGA, FGB. So in order to calculate the normal force, let me here take my coordinates to be the following. X, Y. Okay. So if I look now at the normal force, which is perpendicular on the x-axis, which is perpendicular on this surface, then I know that this normal force, if I apply sigma Fy equals to 0, because it is perpendicular on the x, on the y only, I can see that this gravitational force can be projected on the y this way. So if I project this force right on the y, I get F Now, if this is 68, this is the complement, 22, then this is 68. So FGA cosine 68 is the projection, 68 degrees. So I can write here FNA minus FGA cosine 68 degrees equals to 0, right? I need FNA, so FNA equals to FGA cosine 68 degrees. FNA equals to FGA is MAG times cosine 68 0.37. FNA is MA is 28.5 times 9.8 times 0.37. FNA equals to 104.63 Newton. Any questions so far about how did we calculate the normal force on box A at rest? Okay, good. Now let's go to the next part of the question, which is part B. Determine the magnitude and direction of the acceleration of box B, between two parentheses here. Hint, use Newton's second law to write an expression relating the forces acting along the incline on box A and its acceleration, as well as one relating the forces acting vertically on box B and its acceleration. The accelerations A for box A and the acceleration for box B are equal in magnitude, and so are the tensions acting on each box. You will have two equations and two unknowns. So how do we solve this problem? Relying on the tension being the same and being able to write the Newton's law equation for each box, I will be getting two equations. Okay, I have a question here. Number one, let me start with the second question. When I was calculating FNA, FNA has only a component on the y-axis, has zero projection on the x-axis. The tension force is perpendicular on the FNA, right? So the projection of the tension on the y-axis is zero, does not contribute to the FNA. So if we look at, if you think on rotating the graph such that this surface is horizontal, you will be able to see why the tension has no correlation whatsoever with the FNA, right? Take the projection based on the coordinates that we have picked. You will see that tension has zero projection on the y-axis. This is number one. In answering the second question, or the first question, can you please go over how you decided FGA would be cosine and not sine? Okay. Now, if you look at this triangle, if this angle is 68, assuming it's not accurate, the triangle is not to scale, but however, if this angle is 68 and this is 90, then this angle is the complement, right? So it should be 22. So if this is 22, then this one is the complement, 68, right? So if this one is 68 and I need to project FGA on this axis, it would be cosine 68. Did I answer your question? Is it clear now why we picked cosine, not sine? Okay, that's good. That's great. Now back to our question here. If I am to write the Newton's equation for this mass by itself, for this box by itself, I would be writing the following using this coordinate. I will be writing, of course, it's sigma f x even equals to m a. So I have minus t. Now I have here FGA, not cosine 68. Now I am projecting this FGA on the x-axis. So now FGA will be cosine 22. So minus t plus FGA cosine 22, because the angle here is 22 and I'm projecting it on the x-axis. Right? So minus t equals to m1a. Right? This is for this one by itself. So let me write this again. Only for a by itself, I have the t here. I have this one. This is 68. So the projection is, this is FGA. So this is FGA cosine 22, right? FNA has no effect here. And the projection FGA cosine 68 has no effect here, equals to M1, the mass of, I call it MA, the mass of A times the acceleration. So this is the first equation for box A. And again, by defining the tension in the rope here, we can write the Newton's equation for box A by itself, because now the tension force here will be basically the representation for the second box. So this is my first equation. My second equation will be for the other box. However, I want you to pay attention to this. If I am taking the motion to be positive going down the surface, I have to pay attention to the positive direction also. So I will pick the positive direction to be going up, such that the motion by going up means sliding down. It doesn't matter sine 68 or cosine 22, they're the same. It doesn't matter how you look at it, but at the end, they are the same. I look at here as like this. This is that's my coordinate. My coordinates are like this, and I have a force. So this is my y, this is my x, right? So this is 68, then this is 22, and this is 68. So it doesn't matter. You want to, if you project this on this axis, it is cosine 22. If you project on this axis, it is cosine 68. So this one is cosine 22 if you project it on the x, or you can say cosine 68 if you project it on the y. Okay, so now back to here. So if I want now to write Newton's equation only for box B, it will be as simple as positive direction going up. It will be T minus FGB equals to MBA. So I have here the first equation for the first system. I have the second equation for box B. Now, 1 plus 2, I can get rid of the tension of the T. I'll end up with FGA cosine 22 minus FGB equals to MA plus MB. FGA is MAG times cosine 22 minus MBG equals to MA plus MB times A. Substituting here, I have MA 28.5 times 9.8 times cosine 22.93 minus MB 21 times 9.8 equals to MA plus MB 28.5 plus 21 is 49.5 A. A equals to 28.5 times 9.8 times 0.93 to 59 9.75 minus 205.8 divided by 49.5. This gives a 259.75 minus 205.8 equal divided by 49.5 as 1.089 meter per second squared. So this is the magnitude. If you want to write it as a vector, say 1.089 meter per second square upward. Okay. Any question about this problem? You're all good? Okay. In this case, we'll end the session and we'll see you on Monday. On Monday, we will go through the slides that I have posted and the lecture that I have also posted. Quiz 2, my understanding the long answer question will be posted soon or maybe posted. We should be able to look at quiz number 2 and solve some of the questions. But this is going to be for Wednesday. That's going to be for Wednesday. For Monday, we'll be going through the lecture that I have posted already.